Okay, thank you, Jason. Good afternoon. We can now say good afternoon. I'm the guy that's keeping you from lunch, so I'd like to very much appreciate your, I certainly have a lot of gratitude to your intestinal fortitude to basically sit through this. I've actually been quite blown away by that last presentation from the Bloomberg folks, and it really shows just how far we've really come, in this, in the Spark community over, like, God, I mean, last year or so. I mean, basically a year ago when they did the first Spark Summit East, it was like everybody was discovering this hot, shiny new thing. And now we're talking about data management. And the other thing also, we're getting a little bit of feedback here, so you may want to adjust that. Is I think also what we saw in the last half hour, I think is going to be kind of a leading indicator that I would expect within the next year or so that we're going to find some third-party tool provider coming up with a new tool for managing data frames, because as organizations, as enterprises are starting to expand their implementation of Spark beyond that first pilot project, they're going to start finding out that we're hitting on certain constructs of data, certain data frames more frequently than others, and why do you want to reinvent the wheel every time? Classic case for tool development, and by the way, this is the exact same thing that happened in the data warehousing space 20 years ago. And the thing is, as a community, we've been very successful in talking to ourselves, and that up till now has been a great thing, because how do you get the fire going? Is that you're not going to get the attention from those who are writing the checks unless basically there's some critical mass here. And what you've done over the past couple years, besides it's being the most active Apache project, you've gotten phenomenal vendor support. And just most recently, about 6 months ago, IBM just going in full frontal on this with committing 3,500 practitioners, developers, to developing applications and tools that either use Spark or run on Spark. So you basically, this community really deserves a huge pat in the back. But what it means is it's time to take it up, I guess, take things up a notch, because at some point you need to talk to the folks who are writing the checks. And that's really what this talk is all about. And it's really, implicitly, it's what a number of the presentations, I know, like I have some colleagues from the analyst world, Nick Ruda and Mike Gualtieri, who will be on this stage a little bit later on today. And we're basically all going to be reinforcing the same message. Of course, Sean, Connolly from Hortonworks, I think, kind of took a lot of the words out of my mouth before. It means you'll get to lunch a lot sooner, so that's the good news. But anyway, so basically this slide here really, this really needs no explanation. You folks know, this is the type of thing that I have to present to external audiences who are trying to find out what is Spark and why should we be paying attention. But the fact is that this thing has just gone so viral, and I just want to show one small indicator there, which is basically the job trends chart. And the blue line is demand for Scala developers, Scala programmers, and the small orange line is Spark, is basically Spark developers. And you think, well, when you look at that, well, gee, Spark doesn't look so, looks pretty trivial, except that what I really want to point out is that Spark is brand new. Basically, it only started to appear on the, basically demand, basically as of maybe 2 years ago. But what it's done, Scala was a niche programming language. It was a very interesting offshoot of Java. And once Spark came on the scene, of course, Spark was written in Scala. It just exploded demand for Scala developers. So if folks had type safe, I'd be really happy about that. But anyway, so all this, the fact that this has been the most active Apache project, the expectations of this are not, they're not too great. It's only, Mike Olson a couple years ago, when Cloud Era basically discovered Spark and began supporting it, basically called Spark the leading candidate to become the successor for MapReduce. And then just last year, when IBM basically put its muscle into it, they basically equated, and you heard this in Angel's presentation earlier this morning, that the significance of the Spark open source project will have the same significance, the same degree of impact on the enterprise as Linux did about 15 years ago. And I remember some of those old Linux Expo sessions at Javits, basically were like, what the hell is this thing? And now basically it's become the default platform for running anything outside the Windows arena. So the expectations on you folks are not too great here. But anyway, as practitioners, we're probably all basically attracted to the shiny new thing, and we want to get that new thing on the resume. And so so part of the interest, amongst you folks, amongst the practitioner community, is that this is new, and I want to basically get my hands dirty on this. But the fact is that, and so why are we so jazzed about this? Well, first off, basically, compare this to MapReduce. It is much easier to develop against Spark. You have a much higher level programming abstraction. You don't have to program all those maps and reduces. Spark, you write to an API. The performance, basically the way Spark is optimized, and I'm not even talking about in memory here. Even without in memory, it executes 10 times faster than MapReduce because of the way that it basically optimizes all the computes, and also the fact that it can basically instantiate common data objects, so you don't have to keep rewriting them all the time. Going into memory, of course, jumps that up by another order of magnitude. Flexible, and if you heard about what we heard earlier today about structured streaming, I'm not sure if I have that term correct, but basically, it's sort of it's kind of a potentially very interesting step. But the fact is, what's neat about Spark before this was that on the same engine, you could do batch and you could do real time. You could combine this. This is essentially the Lambda architecture realized in a single compute engine. Now with structured streaming, you can actually do this within the same programming flow. Of course, extensibility. There's a Spark, there's the core compute engine. Then you have the 4 libraries that come with the project, Spark SQL, MLlib, GraphX, God, I'm having a senior moment here on the 4th one there. But the thing is, what's really interesting here is that it's not just limited to those 4 libraries. But at last count, and I'm sure this count is out of date by now. Last summer, I counted roughly about 80 additional third-party libraries that have been certified to work against the Spark API. So this is tremendous. You have lots of extensibility here. And finally, of course, I sort of hinted at this when we were talking about flexibility. You have this versatility. You can orchestrate multiple analytic processes. Now, what I'm telling you here is not news to you, but the fact is, if you're trying to take this message to the enterprise, is that going to impress this guy? Because so far, what you've talked about is how this is going to make your life easier and do cooler things, but you've not told them anything about what this is going to do, how this is going to impact the business. And so let's try and take this up a notch. So, okay, ease of development. Well, it'll mean that the quality of the coding is going to be better, fewer errors. You'll be more productive. And with performance, what's kind of interesting about that, this sort of reminds me a little bit, basically back about 20 years ago during the age of when you went through the heart of the heyday of Moore's Law, where each year you got workstations that were twice as powerful. I remember at that point that really made desktop CAD/CAM doable. And so when each year when you got a RISC workstation that was twice as powerful as the last one, did that mean that an engineer solved their problem twice as fast? No, basically, a problem like any mess expands to fit the available space. And so in this case, you probably put twice as many variables. But the result is that you basically did a better computation. You did a better simulation. You got better results because you used more data. And so the same thing really goes with Spark. And the fact is, if you think about what is made possible with machine learning, it wasn't that you couldn't do machine learning before Spark, but what if you had to do it through MapReduce, where it might have taken hours to go through a single what if, and say, to a point where you can now do this within minutes or seconds, you can now get meaningful machine learning. You can basically produce meaningful machine learning results. You can get meaningful results. So speed makes a huge difference, not just in basically your solution time, but the quality of the results you can get. Now with flexibility, when we can start combining batch and real time, your predictions will get smarter because you can take in past history. And as you look at the present, you can adjust your models. So when you can combine these two, you get a much more reliable result. Of course, with extensibility, as I was mentioning before, it gives you wider tool selection, so you can tell your bosses, well, there's less chance of vendor lock-in here. And finally, orchestrating multiple analytic processes, you can handle more varied scenarios. So basically, at that point, what do you think this guy's going to say? I mean, have you communicated with them yet? Maybe you think you're getting warmer, but this is still not telling them anything about how this is going to impact the business, because basically you haven't told them anything about basically what this is going to do, to your revenue streams, for instance, or your profitability. Or will this make it possible, like with web trends earlier, the example that was provided by Sean earlier today, that as a result of using Spark, they were able to come out with a new product. So this is the type of thing that gets the attention of the folks that are writing the checks. And again, as you start to industrialize this, as you start to basically work this into your development processes, your analytic processes, you're going to have to deal with the folks who are writing the checks here. So the key here, basically to communicate with these folks is really looking at which use cases, which business scenarios can Spark address. More specifically, how is Spark going to impact how you run analytics? So what questions does Spark enable you to ask? How does it enable you to ask them? Because when you can run these what-ifs 100 times faster, what does this mean in terms of all the what-if scenarios you can run and the type of and the types of algorithms you can throw at it? What types of analytics can you perform? For instance, streaming. Not exactly the type of thing you could do with MapReduce. How timely will your results be? And as a result, the grand result of all this is how is this going to make a difference in terms of what results you can get? This is really what you need. This is really where the dialogue has to go. And so the rest of the time, I'm going to basically kind of repeat a mantra from what you saw in the keynotes. I'm going to talk about some use cases. But specifically, I think what you're going to find, there are going to be some exceptions, like with with the web trans example. That was a new use case. It was a new product. But the fact is, I think in most cases, it's just going to enable you to deal with existing problems more effectively. In fact, what we found in our research on big data, this is before Spark, was that it wasn't necessarily a case of new use cases. It was a matter of that we started to look at customer engagement differently, or risk, fraud, and security operations, or workload shift. These are things that we were already doing, but now with big data and now with Spark, with big data we can become more global in our analysis. With Spark we can become basically more current in our analysis. So let's get into some examples here. And this is a case of, we were talking about orchestrating before. And when they were mentioning structured streaming earlier today, I was thinking exactly about this one. But basically, this is an existing application. You're trying, let's say you see those variable, those electronic signs on highways that basically tell you, how long it'll take you to get to the next exit, or there's an accident, maybe you should take an alternate route. This is basically being done from a control center. I mean, so this is not a new application, but with Spark, basically with these different Spark processes, you can be a lot more flexible with this. You start with streaming, obviously. This is real-time data. That data may come from various different things. It may come from sensors in the pavement, may come from GPS or mobile data, what have you. This data is streaming in. You're doing these analytics and you're seeing where, and you're basically looking for exceptions. In other words, like where are we starting to see some slowdowns? And then at that point, you could then do an interactive query. This is exactly the scenario they were talking about earlier this morning with structured streaming. So in other words, like what is it about that particular bottleneck at the intersection at exit 48 or whatever it was. And then based on that, you can obviously you can then start to change your signs. But also, what's kind of cool about this is then you could also apply some long learning machine learning processes here to see, are there certain other certain extrinsic factors that are impacting the trending of traffic flows here beyond all that. So what's kind of cool is that you can do it within the same engine, and with some of the new innovations with structured streaming, you could probably do this within the same construct, the same problem, the same program. Another example here, and I believe this was delivered last summer at the Spark Summit conference in San Francisco. It was a it was a pilot project from Toyota. And basically, it's monitoring automotive performance. Again, automakers have always looked to find out how their products are performing on the road. But usually, they got the information after the fact. I can give you a personal example. It wasn't a Toyota. It was a Honda Accord. And we had an Accord with a standard transmission. And our warranty, like most new car warranties, wore out at 36,000 miles, and at 38, basically the transmission was acting funny, and I went to the dealership and they were in denial. I was like, no, this is a brand new transmission. 40,000, I couldn't drive the car anymore, and so I took it in. And basically, since it was so close to warranty, I got Honda to basically give me half the money back. And they found 80,000 miles, the same thing happened. And I brought it into another repair shop, and the guy did some research. It turns out that they cheaped out on the gear housing. They put it in plastic instead of metal, and so it turns out after the fact, Honda found out that its gear housings were defective. Well, had we had social media at the time, I would have been tweeting this. I would have been sending this out on Facebook, and they would have heard about this before I even got to the dealer. And so that's basically what this Toyota experiment was all about, this pilot was all about, was to identify signals, not so much from basically when customers went into the dealership, but basically to look at what they were saying on social media. And they used Spark MLlib machine learning, basically, to try and say what can we learn from what people are saying, what terms we be looking at. And the results is that this provided an advanced indicator, an early warning light, if you will, on basically on the experiences that customers were having. And what was kind of cool is that the MLlib libraries eliminated the need for the folks on the Toyota team to basically do all this themselves. They could basically just invoke these libraries. Anyway, another example here, data wrangling to spot financial fraud. I cannot disclose the name of the company. It was a Paxata customer. And they traditionally, in this case, this is a company that does, forensics they're consulting firms, and they're very well known one, I cannot mention their name, that works with the financial industry that does financial forensics. And traditionally, they did this through a data warehouse. In a data warehouse, you can only do a sampling of data. Obviously, with big data, you can now look at all the data. That's one of the key advantages of big data. But the problem is that traditionally with MapReduce, it's like you'd still be in a batch process, and it would take you a long time. You'd get great insights, but it'd be after the fact. What they use Spark, machine learning powered, machine powered data prep tool to basically harmonize the data, and from harmonizing that data, which they were using Paxata in this case, they could spot those outliers a lot more quickly. The benefits was that basically it enabled the team to basically expand the data pool, and they could now query this interactively instead of conducting a batch run. And they could also run more what-if scenarios for spotting fraud. So they were able to help their customers become a lot smarter in spotting and preventing fraud, nipping it in the bud. Another example, this is just more of a generic composite example, and you've heard some variants of this earlier this morning in the main stage, but it's the classic customer experience, customer 360. And what we found, and this is even before Spark, is that especially amongst B2C companies, this was the most popular use case for running analytics on Hadoop. And we see this as being also a very with Spark, it basically it enhances this even further. Traditionally, we relied on surveys or focus groups or data from our transaction systems like CRM systems. And from there, basically, with Spark, because of basically the improved performance, which allows meaningful machine learning, we can now provide more forward-looking predictive analytics so that we can improve the customer experience, lose fewer customers, maybe upsell more customers. I mean, it's a very standard, as I said, it's a very standard use case. And so you can use Spark-enabled machine learning for identifying, basically trends in what customers are saying, kind of like that Toyota example. You can get a much better idea, basically, on customer satisfaction levels, and you can use GraphX, and that, I think that was the library I forgot to mention before, to look at the relationships between these folks. What is this person who's basically making a comment? Is this person an opinion leader? Do people listen to this person? Or is this person a listener? And chances are this person may be a thought leader in one group and maybe a listener in another group. Graph analytics can chart those many-to-many relationships. And in turn, it also can be used for basically tracing the path of this customer as they interact with you and they interact with other people. So the benefits of this is that this changes customer, basically, the whole customer 360 strategy from being reactive to proactive. Anyway, so what has this done to our tech argument? Basically, I mean, what we're coming from here is that we're going from talking about how Spark makes us more productive, makes analytics more flexible, and we're basically getting, now basically we're transitioning to basically articulating this in terms of real business benefits. And so, for instance, with the Toyota example, the business benefit is that you could head off product complaints, you could nip product liability issues, product defect issues in the bud, because you're listening and you're hearing these signals a lot sooner, and you're figuring them out a lot sooner. With financial fraud detection, the benefit is that your sleuthing basically is much more thorough, and it's much more timely, and that's very critical when you start to see some fraud. With customer experience, the benefit is basically staying more in sync with your customers. You're acting rather than reacting. So what are basically the takeaways? Is that Spark enthusiasm in the practitioner community really has gone viral. And basically, as I said, you have yourselves to pat on the back for that in terms of that you folks basically have really, have formed a huge committer base and are really doing incredible things with the technology and in applying the technology. As we saw with the Bloomberg folks, are really are taking this to the next level. For instance, when we can start to basically instantiate data frames, now we can manage them. So you're doing some very amazing things, and the vendor community has listened. You have, so the vendors now are supporting you with lots of products, and that's a good thing because you don't want to have to invent everything yourself. And so the key here, though, is that as Spark-based analytics start becoming more mainstreamed, you now need to talk to the business. And so the key is keeping your message real. Basically, speak in terms of business benefits. Don't promise the sky, because Spark is still a maturing technology. There still are hiccups. For instance, there still are hiccups with scaling, with basically but that's typical of any young technology. And the fact is that the amazing thing is that Spark making basically doing things like, for instance, like addressing memory management so early on is a sign of the support in the contributor community. Spark is not the only path to machine learning, of course, or graph or streaming, but the key thing with Spark is that you have this API compatibility, and that provides accessibility and basically enables all those great things, which basically to a business means we can buy more tools, we can perform more analytics, we can get better answers. As I said before, keep in mind that Spark is still in its adolescence. So at this point, that pretty much concludes my end of the presentation. Do you have any questions?
I'll come around and pass the mic to you.
So you showed several use cases in financial industry and automotive and all this. So do you have any idea for healthcare industry?
Well, put it this way, it's like, it's kind of like, it's limited by the imagination. Basically, I can imagine, for instance, like looking at, let's say, medical devices, in the ICU, for instance. Is something happening there? Basically, are we getting different results for some reason, some external factor happening? It would be useful for clinical research. It would be useful for cancer detection. It's just the possibilities are just limited by the imagination.
Do we have any other questions? I'm not seeing any.
And I'd be happy to talk with you offline.
I had one question. A lot of your use cases can be boiled down to either, generating new revenue with new products, or, controlling churn, or, cost control, trying to reduce costs. Do you see like a mix of, one being more in demand than the other?
Well, I think that has more to do with the macroeconomic climate. In the past few years, that we've actually been, I think, in more of an expansion phase. This year is kind of like, we're sort of wondering like what's going on here. So I think businesses were being more aggressive in trying to basically up the top line as opposed to basically worrying as much about the bottom line. So I will say that up till now, it's been more about basically, building revenue. I can't really make any predictions on 2016. We need some machine learning for that and predictive analytics.
Okay, so when you look at the enterprise landscape, so most of the enterprises, for them, it's very important to have data governance, security, and a lot of processes built around these two areas. Where do you think Spark is today in terms of data governance, security? What are some of the issues, and where is that going from your perspective?
Where do we start? First off, I think you have to think about this, number one. Are we talking about Spark on a standalone platform, or are we talking about Spark being managed under Hadoop? Now, if you're talking about Hadoop, I think the data governance there is light years ahead of where it is in Spark because, of course, the project has had quite a bit of a head start. That said, data governance in Hadoop is still nowhere near that we have for relational databases. And so, I mean, were you here for the Bloomberg presentation just before this? Okay. One of the things that they had to engineer, they were basically coming up with a managed data frame registry because they're finding that we're using this so much, we're using data frames so much. And they didn't talk about governance, per se, but one of the functions that they talked about was we had to look at life cycle. And part of governance is life cycle. And they had to indent that technology themselves in their registry. So basically, there are some basic security mechanisms that Spark can take advantage of, and they can take advantage of. Let's say if you're working, let's say, with a Spark cloud service provider, Amazon has certain sort of perimeter protections and that type of thing. But at this point, Spark as a standalone platform is still, to me, largely a blank slate there. And I think basically. This is going to depend on whether you implement Spark standalone or whether you implement Spark on a data platform that already has these features.
Got one more here.
Thanks. You mentioned that Spark is in its adolescence. What exactly does that mean for people? Does that mean wait and see? Does it mean aggressively move forward in your innovation center? Does it mean start some pilots and check carefully? Does it mean hire IBM? Spell that out a little bit.
Hire IBM. They paid me to say no. At this point, what it means, I think it's definitely safe to do pilots. I think basically the issue with Spark at this, there's several things. One is that basically if you're going to implement standalone, there's really no governance or security at that point. Also, in terms of basically, stability, it's like any in-memory architecture. If you have to size these problems so they fit into memory. Yes, Spark can spill out the disk, and yes, the Databricks folks tell me that yes, you can do this pretty easily. I've heard other results from the field. So I think, there's some teething issues with regard to basically fitting data into memory and sizing problems. There are also issues in terms of, just brute scalability, which probably for the average enterprise won't be that relevant. But as of last summer, I think the largest Spark cluster I'd heard of was up around 900 something nodes. So it's not going to be as, MapReduce is still a more scalable, process if you're trying to basically get the sheer brute force scale, dealing with petabytes of data. I think for what most enterprises deal with, and so I'll say quote unquote medium data, Spark should be fine, but again, with the proviso that your problem can be sized so that it fits in a memory, so you'll have as few hiccups as possible. So those are the things that stand out in my mind. I'm sure there are others, but those are the things that stand out.
All right. We are at time and ready for lunch. So let's give a big round of applause for Tony for his time.
Thank you.
Thank you very much.